Hello students, welcome to engineering geology classes. In today's class we will discuss about what is GIS and GPS. So GIS stands for the Geographic Information System. So what it is? So a Geographic Information System, it is called a GIS. It integrates the hardware, software and the data for capturing, managing, analyzing and displaying all forms of geographically referenced information. Means what here? The GIS, it is a software, so it includes both hardware, software and the data which is captured, okay, and the managing of data, analyzing of the data and displaying all the forms of geographically referenced information, that is called as a GIS. Okay, so GIS is relatively a broad term that can refer to a number of technologies and processes. So it is attached to many of the operations in engineering, planning, management, then transport and analysis, and there are different components of GIS. So we'll see first what are the components of GIS. So the first one is hardware. So hardware, basically it includes your computer system, okay, or the CPU, that is central processing unit, okay. So it is linked to a disk, that is a drive storage unit, which provides the space for storing the data and the program. So along with the monitor and CPU, you also need a digitizer, scanner and other devices which we need to convert the data. If we have a hard copy of the map, then if you scan that, it will become a soft copy. So such scanning devices, then the digital form, to convert it into digital form, okay, and that digital information is sent to the computer. So there are number of elements that are essential for effective GIS operations. So these include that is the components of hardware. They include the presence of a processor with a sufficient power to run the software, like we use ArcGIS software for image processing and all. Then we need sufficient memory for storage, because it will generate a large volume of data, so we need hardware to store that data, okay. Then we need good quality high resolution color graphic screen, okay, so that the interpretation becomes easier, okay. Then we need data input and output devices, okay, scanner, keyboard, printers, plotters, all these are the hardware which we need for that is one of the component of GIS. Then next is software. So software includes what? It is a program, okay, and that includes a program and the user interface for driving the hardware. The GIS software, it generates, it stores, it analyzes and it manipulates and it presents geographically referenced or correlated information or the data. So it is essential for driving the hardware, software, okay. So the software includes not only the core GIS modules but also the various data drawing and manipulation. Then even we need to do statistical analysis, okay, then drawing and visualization, then integration, then imaging and the database and other softwares, they are required for capturing, then displaying and analysis of the data. So the basic modules of software are: first we need the data input and verification, then we need data storage and database management system, right, DBMS. Then data transformation and data manipulation has to be done, so that also comes under software. And we need the output from that whatever processing we have done, so data output and presentation. So these are all the software requirements. Then the next one we need is data. The next component of GIS is the data. So geographic data and the related tabular data, they can be collected uh, and compiled, okay, to custom the specifications and requirements, okay. Or we can purchase from a commercial data provider. The data we can purchase also, right. So a few datas are free available, few datas we need to purchase. So a GIS can integrate the spatial data with other existing data resources, often stored in a corporate, that is DBMS, okay, that is database management system. It will store the data. So the integration of the spatial data and the tabular data that is stored in a DBMS, that is database management system, that is a key function which is preferred by the GIS. Then we need people, that is the most important part, that is the GIS technology is of limited value without the people who manage the system and develop the plans for applying it into a real world problem, right. So we have all the data, but if we don't have people to process that data, then it's of no use. So we need skilled people who know how to interpret, how to extract the data from that, and how to apply that knowledge to overcome the problems. So the people are the core to the GIS, both the technical specialists who develop and manage, okay, the system, as well as the end users who are going to employ the technology. They are the crucial to the success of GIS. So identification of GIS specialist versus the end user ID, that is often critical to proper implement the GIS technology. So there is a lot of scope in this field, that is if we learn the technology, that is how to use the software and all, then it has lot of opportunities, okay. Then the last one is method or procedure. So here method refers to a well defined consistent procedure, okay, that are required to produce accurate, then reproducible results, okay. Proper methods to produce the proper results. So a neatly conceived implementation plan and the business rules, that are the models and operating practices, they are unique to each organization, okay. So there is a need to properly integrate the sophisticated tools which are available through bringing well defined procedures in well documented form into entire business strategy and operations to make this technology of GIS very effective. So the metadata, that is the data about the data, okay, that is the key for documenting these processes. So these are all the components of GIS, so which are very very important, okay. So what is GIS? It is a integrated geographic integrated software, right. Integrated hardware, software and data for capturing, managing, analyzing and displaying all the forms of geographically referenced information. So that is called as GIS, Geographic Information System. Then next we'll move on to GPS, that is Global Positioning System. Nowadays everyone is using GPS, right. When you go to an unknown place, you on your road map, or you are on your GPS, so that it will take you to your destination. So that is a GPS. The full form is global positioning system. So it will place you globally anywhere on the world. Okay, so it is a space based global navigation satellite system, that is a GNSS. GNSS stands for the Global Navigation Satellite System. So this provides a reliable location and the time information in all weather and at all times, at and anywhere on or near the earth. And when and where there is a unobstructed line of sight at to four or more GPS satellites. Then how this GPS works? So there are three segments of the GPS. One is the space segment, one then the control segment, and the user segment. So these three segments are very important. That is the space segment. It will send the information from the space to the control segment. Okay, the receiving stations, okay, on the ground. Then these receiving stations or the control segment, they transfer the information sent by the space to the master station, and from there it will again send to the space segment, that is satellites, and they will again show us our location, that is the user segment. If we are using GPS instrument or a device, or even your mobile GPS. So this the GPS that was created and by the US Department of Defense, that is, and it was originally run with the 24 satellites. Okay, so it was used with the 24 satellites. Then it was established in 1973 to overcome the limitations of previous navigation system. So the GPS program, okay, it provides a critical capability to mainly for military, okay, then civil and commercial users around the world. So in addition, this GPS is a backbone for modernizing the global air traffic system. So the air traffic, what we call nowadays, that is controlled mainly through this GPS. So there will be a GPS receiver, okay, that calculates the position by precisely timing and the signals sent by the GPS satellites with high which are above the earth. So usually these satellites, they are at 36,000 kilometer above the earth, they are revolving. So this is a space segment, okay, in which the satellites are revolving around the earth. There are few satellites which are at constant place, they are called as geostationary satellites. Okay, then there are satellites which are continuously moving along the defined path. Okay, so there are different satellites which are revolving around the earth. Then there are control stations. So there are master control stations and some minor control stations which are situated at few states, okay, few countries. Okay, the control segments are located mainly main stations. Okay, you can see they are situated globally. Then the next, how it tracks your signal. Okay, the signal from one satellite, the receiver is somewhere on this sphere. So if your GPS is showing the information only from one satellite, then it will place you in this circumference. Okay, then if your signal is tracking the signal is tracking the two satellites, okay, information sent by the two satellites. Then you can see by triangulation method it will give you the position, okay, somewhere here. Then the third satellite, okay, 2D positioning with the help of three satellites, then triangulating correct position of your, okay. So like this, if you have more number of satellites, the your location will be more accurate. So minimum 4 satellite we need to locate the position of any person or any vehicle on the earth, okay. So minimum 4 satellites are required. Then we'll see what are the applications of GIS and GPS in civil engineering. So it helps to implement the corrective measures and maintenance during the construction. Then it helps in verification of design hypothesis and construction processes. Then it helps in regional planning and site investigation. Then it also helps in hydrogeological and geomorphological information along with the geological structures which are derived from satellite data. They are very useful in locating the groundwater boreholes also. Then it helps in development of national infrastructure and planning, because they provide the solution which is related to many environmental issues, okay. Then the image interpretation that can be used in variety of ways to help monitor the quality and quantity of water resources which are available. Then it helps in exploring the groundwater prospect zones also. Then the sediment pollution is often clearly depicted on the aerial and space images, okay. Whatever pollution which is taking place in an reservoir, that also you can find out. Then it helps in preliminary investigation of impact assessment of dams and rehabilitation. Then GIS provides a valuable tool in the process of planning and designing of highway, bridges, tunnels, etc. Then this remote sensing, it plays a vital role in delineating potential areas of groundwater occurrence for a detailed exploration, so thus reducing the cost and time which is involved in groundwater exploration. So through satellite images also you can do the groundwater exploration, okay. You can identify the potential zones for groundwater. Then GIS can be used in flood monitoring, wetland management, forest management, land degradation and watershed management. Then this GIS can also be used in land use, land cover change analysis, urban planning and monitoring. That is how it was in suppose for example, if you want to take up a area before flood, after flood you can study, or before urbanization, after urbanization. Suppose for example, you want to study a particular developed area and how it was before 2010 or before 2000, how it was and what is the present status. So you can do the analysis, okay, using GIS. It will give you how much water bodies have lost, how many buildings have come up, okay. So all that you can find out what all changes and how the changes have taken place. Then it can be used in locating underground pipes, cables, planning facility, maintenance, telecommunication network service, urban planning, regional planning and the development of public facilities. So these all are the applications. Then it can be also used in locating the houses, streets, okay, car navigation, transportation planning. So all these are included under the applications of GIS and GPS. That is a very important question, that is what is GIS and GPS and its applications. That is a very important question from exam point of view. Thank you.